Hello. Okay, should see the desktop now. Should hear me. Everyone, everything seem okay?
Hello.
Good,
Yep, looks good.
good,
Sounds good.
thanks. Okay, I'm pulling up the chat. I have some windows to pop up. Okay, all right. Okay, people are coming in. Okay. Ooh. Okay, today we're going to keep on talking about arrays. Okay, we're going to do some more examples of arrays. Mostly what we're doing are this reference on traversing arrays. There's a lot to say about traversing arrays, lots of examples. There's now, it's not a very complicated idea, but there's lots of examples and lots of issues that come up when lots of things we can do when we traverse an array. So we're going to keep looking at various examples of array traversals and what kind of problems you can solve using arrays and traversing arrays. Okay, and there's this one book has got some nice homework problems for arrays. So one thing you could do to keep practicing arrays is this page is a bunch of these mixed up coding problems. So do these. They're very good examples to make you just think about how array code should be structured. And then on this other page, this is a page of programming assignments where you have to write the code, either you have to modify the code they gave you or write code yourself. And I suggested that you do these here. I mean, you can do as many as you want, but I suggested you do those. I think those were the most interesting problems on that page. Okay, so those are practice problems for arrays. And also, I started grading exam one. It's going to take me a couple days to grade it. So hopefully the grade's going to be done by about Thursday. So I started this morning grading exam one, but it takes about 2 days to grade an exam. Okay, so hopefully you'll get your grade for exam one soon. And like I said before, if you see the grade up there, that means that you can look for the exam itself and make sure you look at the exam itself. You should be able to see the document you uploaded. I modify it. I what we call annotate it. So I circle mistakes. I make comments on the exam. I write down the number of points you got for each problem, so you could see how many points you got on each problem, whether you made mistakes or if I wrote suggestions. Okay. So please make sure you look at the exam document. You should see the annotations on there. Okay. And if you don't, let me know. I mean, everybody should see at least some annotations on their exam. If nothing else, there's the number of points you got for each problem. So if for some reason you don't see that, let me know because you should see it. Okay. And you should be able to download the exam and print it out with the annotations if you want to. Okay. Like like uh like at the end of the semester, you'll lose. That's actually a good point to bring up. At the end of the semester, you'll lose access to those exams, and you may want to keep them for future. Like if you want to study in the future, like if you take the second course in programming, or if you just want to look back at them, you should probably download them and keep them on your computer because Blackboard's kind of a funny. It's one of the reasons why I don't like using Blackboard and I prefer using a website. You lose access to that course in Blackboard at the end of the semester. And I think you actually do lose access even to your exams. I mean, the intelligent thing was they would let you keep access to your stuff, but I'm not sure if it even works that way. When you lose access to the course, you may actually lose access to things like your homework and your exams. We haven't been using Blackboard for that long, so I'm not positive, but that's the way it was in the last course management system. Students would lose access to even their own homework and their own problem and their own exams because they just lose access to the course. Okay, so I would suggest that you actually download your exam and keep a copy of it for yourself. Okay, so let's. The examples I want to do today, I haven't put them up on the website yet. So after class, I'll put them up. I have them on my desktop. So we'll look. I'll put these examples up on the course website after class. So I want to look at some examples that are related to the idea of array traversal. Okay. Okay. Now, what we've done so far, the main example we've done so far with array traversals was this count occurrences, where we filled an array with random numbers and then we counted how many times some particular number appeared in the array. And this for loop here is the basic array traversal. In this case, the array is called random ints, and you start at index 0, you go up to the end of the array. Now, remember, if the array, this is the length of the array, there is no entry. Since we start counting as 0, if an array has length 5, there is no index 5. The last index is 4. So it's real important to have a less than here. You could, if you wanted to, do less than or equal, and then length minus 1 here, but nobody does it that way. It's considered too awkward to read that. You know, the last entry in the array is length minus 1. So you'd go from the first entry to up to the last entry, but nobody likes to write it that way. Okay, you will almost never see a programmer write it that way. We'll always write it as you go up to, but not including the length. Okay, so you use a strictly less than with length here. Now that, remember, that there's no entry at index length because we start counting as 0. So an array of length 5 has indices 0, 1, 2, 3, 4. And index 5 doesn't exist. So that means, so if you put an equal sign, there, now you have a program. You have a problem. Your program will crash because it'll try to access the length element which doesn't exist. Okay, so you got to be careful that that's the best way to write it. Okay, and if you write it this way by accident, what happens now? Suppose somebody accidentally goofs up a little bit and writes it this way. Does the length minus 1, thinking that, oh, I'll just go to the end of the array and stop there, but what's going to happen if they write this loop? Think if the length is 5. Suppose the length is 5. What will this iterate through? What numbers?
0 to 4.
0, 1, 2, 3, 4.
It
No,
won't be able to do 4.
It won't be able to do 4. See, length is 5. So this is length minus 1, which is 4, but it does what?
It's less than 4,
So
so it stops at 4.
So it doesn't get to 4. So it iterates through what numbers? I would be
0, 1, 2, 3.
Yeah, just 0, 1, 2, 3. And you'd lose the last item in the array. And actually, a lot of students make that mistake. They get mixed up between these two ways of writing the for loop. Okay, if I write them side by side, or one on top of the other, the two right ways to write this are, this is the better way, and this is the other way. Okay, if you want, this is the better way, and this is the other. This is the other way, but people don't use it. But you got to be careful. Strictly less than the length, less than or equal to length minus 1. Those are both right, but it's real easy to goof this up. You can do a couple wrong ones. You know, a real easy wrong one to do. A good example of a wrong one to do is that. You know, use the equal sign, but forget the minus 1. And another wrong one you can do is do the strictly less than with the minus 1. Okay, so you can, there's two right ways to write it. This is the one you should remember. You should write your for loop traversals this way. Okay, every once in a while you see somebody writing it this way. Just for some, maybe for some reason they want to really emphasize that they're going from the first item to the last item. Okay, it's pretty rare to see someone who write it that way, but it is correct. But then there's really easy to get these two wrong ones, where you get the less than or equal. You're doing the right one here, but you put a less than or equal to. Okay, that one crashes your program. So this one's wrong, and it crashes your program. Okay. This one's wrong because it drops the last element in the array. It doesn't go far enough. Okay, it loses the last item. Okay, you lose the last item. This one. Okay, you lose the last item. Okay, so you got to be careful about these. One way to really do it, the way you should practice thinking this way, from 0 to strictly less than the length of the array. And then this one is what we're really doing. We're really going from 0 to the length minus 1 item. Okay, and then be careful you don't write these two, because they look real close. Notice how this is one of the reasons why we say programming is all about details. And I keep emphasizing that when you read code, read every single character in the code. Nothing can be skipped in code. Unlike English, where you can skip a quarter of the words on a page and still understand what's going on. Okay, in code, it really makes that and that make a huge difference. Little things like that. You've got to read every single line. That's the difference between crashing a program and a program being correct. Here, this is the difference between correctness and crashing. Okay, the only difference between correct and crash is that extra equal sign. There's nothing you can do in an English paper where you can change one letter of the paper and the paper goes from correct to 0 credit because it crashes. This your program won't even run. Your program will just crash. Okay, just one stray character. One stray character. Okay? Be very, and I keep emphasizing that unfortunately programming is like this. It's about real picky little details, and there's just no two ways around it. You'd like to say that programming is about the idea of writing good code, just like English. You can write a beautiful essay and have lots of grammatical mistakes, punctuation mistakes, but it can still be a beautiful essay that people would admire. But you can't write beautiful code that doesn't compile. It doesn't really work that way. So it's just harder. You have to be very careful. Okay, so this one here, that's our basic array traversal. That's our way of writing it. Okay, now let's look at a similar problem. This one filled an array with random numbers and then counted how many times a particular number appeared in the array. Okay, now let's look at something that it's a little bit similar. I'm gonna do it first in Dr. Java. Okay, there's Dr. Java. Okay, see, Dr. Java started up in the bad state. See, the little circle means Dr. Java is stuck for some reason. They still haven't figured out what in the world makes Dr. Java come up stuck like that every once in a while. So quit it and restart it. Does that ever happen to anybody? If you're using Dr. Java, does anybody else have Dr. Java come up like half the time stuck and then you have to quit it? Does anybody else have that problem?
Yeah.
Does it to you too? Because sometimes that could just be my computer. It could just be that Windows is really weird. It's not unusual for a program to be buggy on one person's version of Windows and not on anybody else's. So I never know if that's a quirk of my computer or if it's Dr. Java. But there are other people have had that problem?
It's only happened once for me.
Once? Okay. But that means it's not my computer. It's something about Dr. Java, and I think it has to do with Windows 10. They have not updated Dr. Java for Windows 10. There seems to be enough differences in Windows 10 that Dr. Java didn't used to be flaky at all like that. I think it's that Dr. Java really ought to be rewritten for Windows 10. I have a feeling that that's what's going on, but it's not going to be me that does it. But the people who own the people who are in control of Dr. Java, I don't think they've had time to do something like that. Okay, so now see, now I can tell from the cursor that Dr. Java came up properly. I want to look at this program here. Okay, now this program's real close to the one we did a minute ago. What we did a minute ago was we filled an array with random numbers and then counted how many times a particular number was in the array. What we're going to do now is fill an array with random numbers and then find the largest and smallest number in the array. So we're going to traverse the array looking for the largest number and the smallest number in the array. So it's an array traversal, but we're looking for the largest and smallest. So here's what it's going to look like. I create my, let's see. Okay, see, I need to import this thing to create the random number generator. I need to import the random number generator. Okay, and I want to create random numbers. This is where I create the random number generator object. Okay, I create an array of 100. Actually, I should shorten that. Well, on here in Dr. Java, I can leave that 100. If I can move up to the Dr. Java, I need to make that much smaller. If I have an array of 100, the Java visualizer won't let me work with something that large. Okay, so there's an array of 100 numbers, and I'm going to fill it with random numbers between 1 and 500. So I'm going to have 100 random numbers between 1 and 500. Then I want to find out what's the largest and smallest. You know, the largest number could possibly be 500. The smallest number could be 1. But since I only have 100 of these random numbers between 1 and 500, I probably won't get 500 as the largest and 1 as the smallest. Okay. Okay. Now here's what the algorithm is going to look like. The strategy is to take the first number in the array and make it your guess that it's the largest number, and take the first number in the array and guess that it's the smallest number. Oh, and here, I don't actually have to start. Now, here we're going to iterate through the whole array. But since I've started with my guesses being the 0th item, I can start that at 1. Okay? I don't have to start at the 0th item. I can now skip over the 0th item because I've stored the 0th item as my guess is with this largest and my guess is the smallest. Okay? Then, for each item in the rest of the array, starting at 1, going up to the end, just like before, there's the pattern for going through the array to the end. I take each item and say, is the ith item larger than my guess so far? Is this item larger than what I've guessed the largest item is? If it is, I replace my guess with that item. Okay, so I update the guess. If the item I'm looking at is larger than what I found so far. Another way to put this is you can call this what I found so far. So if this is larger than the largest number I've found so far, I replace my found so far with this new number. Same with the smallest. If the number I'm looking at is smaller than the smallest number I've found so far, I replace this guy with that. Okay, I replace the smallest with this new number. Okay, I update the guess. Okay, and then I just go through the end, and then when I'm done, this number holds the largest, and this number holds the smallest. Okay, now if we run this, remember it's not so easy to watch the programs run in Dr. Java. So I can run it, and oh, I did get 500 as the largest, so I got kind of lucky. Notice that the smallest number was 5 and the largest number was 500. If I run it again, largest number was 498 and the smallest number was 1. Okay, that's the smallest it possibly could be. Okay, run it again. I mean, this is what you more likely get. The largest number is 499, the smallest number is 10. Now, say every time you run it, since these are random numbers, you're going to get something slightly different. The largest number this time is 495. Now, notice that here's one thing. If I make my array much smaller, notice that I am getting really close to the limits because I'm generating 100 numbers between 1 and 500. So I've actually got a 1 in 5 chance of hitting the largest possible number and the smallest possible number. On the other hand, if I do something like this, only 50 numbers. Okay, now run the program. We'll recompile it. Now I'm only generating 50 numbers between 1 and 500. Notice that now I I still got pretty close to the smallest, but I'm farther away from the largest. You know, I said I'm not getting, I'm not going to get as close to the possible largest and possible smallest as well. Actually, yeah. Because what's my chances now of getting the largest number? I've got 50 numbers between 1 and 500. What's my chance of getting a 500?
1/10.
1 in 10. So yeah, that's not such bad odds. 1 in 10. So every once in a while, I'm going to get a 500 or a 1. Yeah. If you go here to something much smaller, like just choose 10 numbers. Notice I don't, well, I still got the smallest possible number. Actually, surprisingly, I still got a pretty small number there. Okay. Now notice this time, the smallest number is 92. The largest number is 388. Out of 500, the smallest number is nowhere close to the smallest possible number. It was nowhere near 1 that time. Okay. So the fewer numbers I pick, the more likely I am to be far away from, oh, what if I pick 1,000 numbers? What do you expect? What kind of result do you think I might get if I pick 1,000 numbers? I'm going to roll a die that's 500 sided 1,000 times. What's my chance of getting a 500?
Twice.
Well, yeah, it's like you're almost guaranteed. You feel like you're almost guaranteed to get a 500 because you're going to keep rolling this. Oh, yeah. If you rolled this 500 times, you would have almost the chance of 1 of getting a 500. With 1,000, see, 501. I hit, run it again. 501, run it again. 502, I almost got the smallest. Run it again. 502, okay? And let's do one more. Let's do 500 rolls of a 500-sided dice. 500 rolls of a 500-sided die. We're still almost probability 1 will get the highest number is 500 and the smallest number is 1. Okay, 498 and 1. 498 and 2. 502. There's 501. See, I had to roll it 5. I had to play the game 5 times to get 501. Because the probability is not truly 1 that I'll get a 500 if I throw a 500-sided die 500 times. It's not guaranteed that I get a 500 and a 1, but it's like 0.99 or 0.9 probability. More like 0.99. Okay. So this is interesting. Yeah. One thing about programs like these is they let you actually watch probability. We don't emphasize that much in these classes, but since programmers write games a lot and games are based on rolling dice, and almost every game has an element of chance in it, so there's some kind of random number generator. Programs are really good ways to get a feel for how random numbers work, how probability works. Like even running little programs like this lets you essentially do experiments with chance. What does it mean to say that there's a 20% chance of it raining today? Well, you can't run today 5 times. But you can play with probability in a program in a kind of interesting way, and you can get a feel for what these numbers mean. Okay, now let me show you something about this program that's tricky. Okay, this seems like a real straightforward little program. Seems like a real straightforward thing. Find the largest and smallest number in an array. But go up here and look at what it says up here. Finding the largest, smallest number in a non-empty array. The truth is, this program only works with non-empty arrays. Well, is there such a thing as an empty array? The answer is yes. There is such a thing as an empty array. Okay, Java lets you create empty arrays. So what I'm going to do here is, here's where I picked how big my array is, right? Do that. I'm creating an array with how many things are in the array now?
Zero.
0 things in the array. That's the definition of empty. Yeah. Does Java let me do this? Yep. Java and we'll do this in the visualizer and you'll see what it looks like. Java let me do that. But if I try to run this program, it crashed. The program doesn't work. And what went wrong? The logic of my program doesn't work when the array is empty. Okay. Can we see where the problem would occur?
In your
about the-
second for loop.
Pardon me?
In your second for loop.
Okay, actually the problem's not even in this for loop. It's before I get to that for loop. The problem is actually not in that for loop.
Oh, the first for loop, I++.
No, and no, the problem's not in, the problem is not here. It's neither of the for loops. They're not the problem. Let's follow our nose through the code. Here's an empty array. Okay, it's got nothing in it. This for loop is actually okay, because here's what it does. Sets I to 0, then asks, remember, the flow of a for loop is you initialize, test, do the body of the for loop, increment, test, body, increment, test. Okay, so remember, it's initialize, test, body, increment. So let's follow our nose. Initialize, I = 0. Test, what happens here?
It's false
Why is it false?
because it's equal to the length.
The length of an empty array is what?
It's 0.
0, because there's nothing in it. The length counts how many things are in the array. The length counts how many things there are. It has nothing in it. So now is 0 strictly less than 0?
No, it's equal to.
So it's false. So this loop just drops out. So this loop doesn't iterate. It's correct. The loop is correct. It has no work to do. The array is empty, so there's nothing to put in it. Okay, so there's nothing to put in an empty array. So that means now we get to line 23. Okay, what happens here?
There's nothing in the variable largest.
Well, no, where there is a problem here. What's the problem on this line? I'll give you a hint. This 0 and this 0 don't mean the same thing. This 0 here means something very different than this 0 here. Remember, programming is all about details. What did this 0 here mean?
Number of elements in the array.
How many? The number of elements. What does this 0 here mean?
The index.
Okay, the index of the first item. What's the problem?
There's no item in the array.
Yeah, there is no first item. This line contradicts this line. This line said put no items in the array. This is asking for the first item in the array. There is no first item. If you go back down here, you will see that the error was at line 23, which is exactly here. See? If you notice, this error message says array index out of bounds, line 23. Okay? See? It was this line that crashed my program. There is no number to make a guess with. I can't make a guess of the largest number being the first item because there is no first item. My algorithm fails on an empty array because there's no initial first guess. So notice, you said that there was nothing in largest. In a way, you were right, but the error wasn't that there was nothing in largest. The error was it couldn't read the right-hand side of this equal sign. The error was that there was nothing here to put in largest. So you were kind of right when you said there was nothing in largest, but that was leaving why there was nothing in largest, because the right-hand side crashed. The right-hand side crashed. There was nothing to read in this array. Since there was nothing to read in this array, there was nothing to put in largest, but the program actually never got that far. The program crashed on trying to read this number that doesn't exist. So it crashed on reading that number there. Let's put this in the Java visualizer and kind of get a picture. We'll see a little like a picture of this happening. But this shows you how a simple algorithm can fail when some condition isn't met. Okay, here, this simple algorithm is correct on the assumption that you have an array that's not empty. But if you have an array that's empty, then the algorithm doesn't work anymore. And that's going to be an important fact about computer science. Whenever you have algorithms, you almost always have what the fancy word for it is precondition. People sometimes use the fancy term that the algorithm has a precondition. Like this algorithm has the precondition that the array better not be empty. Otherwise, this algorithm it's not guaranteed to work. In this case, it crashes. Some algorithms won't crash if they don't meet their precondition, but they'll give you a nonsense answer if you don't meet their precondition. So algorithms have preconditions. In this case, the precondition is the array has to have something in it. The algorithm presupposes that the array has something in it. Okay, so this is going to be a real common thing about programming, that programs will always say, but before you can use this program, you got to make sure these conditions have been met. Otherwise, the old phrase is garbage in, garbage out. If this algorithm is given what it would consider garbage in, which is an empty array, then it gives you garbage out. In this case, it crashes. Sometimes garbage out just means a nonsense answer. Sometimes it means crashing. Okay, now let's put it in the visualizer. Okay, now let's see. Let me tweak a few things. Yeah, okay. So this is going to create the array of size 0. And we can go ahead and let the visualizer show us what that looks like. Okay. Now notice there's where the visualizer says empty array. Instead of drawing a picture of an array, it just writes the word empty array. Okay. Now we create the random number generator. That was line 12. Now watch what's going to happen in this for loop. The for loop starts off here. There's the initialization part. See, it just did the initialization part. Now the for loop is there. It's doing the test part. And it's going to test that I is less than 0. 0 is the length of this empty array. The empty array has length 0, so it's going to skip from line 13 to line 19. It's just going to skip over the loop. See, there was nothing to do in the loop, so it skipped from 13 to 19. Okay, and we lost I because now we're outside of the loop. Okay, now we're here. We have to do the right-hand side of the equal sign before we can put it in largest. Now you'll notice that we don't even get a largest over here because the program's going to crash just doing the right-hand side. So I click forward and it crashed. See, I didn't get largest. It didn't even get to the left-hand side. It crashed on trying to do this guy here. Array index out of bounds. There is no index 0 in an array of length 0. So notice how carefully you have to read that. This bracket 0 bracket has a very different meaning than that bracket 0 bracket. This one's saying how big the array is. The array has 0 items in it. This is saying I want the 0th item in the array, and the array is like 0, so there's no 0th item. It wasn't designed to be user-friendly. It's designed to be a programming language, and programming languages are, they're tricky. They're sometimes very tricky to read. So you see something like this. The context tells you what's going on. This is in a new. See, the context is that this is on the right-hand side of the word int after the word new. So that tells me I'm creating a new integer array, and this is the size of the array. Here, this is a variable name. See, I created the array. See, that was the name of the array. So this is the name of the array. If I put the bracket 0 bracket after the name of an array, it's saying look up that item in the array. So now this one means something very different. Now it means look up the 0th item, but there is no 0th item. Okay. Now let me show you something that's a little bit tricky. That this stuff is there's even a little bit more weirdness to it than this. Here's another way to create an empty array. I'll call this number. Okay, I'll put a 2 here. I create a list. Okay, if I do this, that creates an array with those numbers in it. Okay, now let's go ahead and visualize that. See, that actually created an array with 1, 2, 3, 4, 5 in it. So the array has length, well, 5, because the number, there's the first number, second number, third number, fourth number. So the length of the array is 5. The indices go from 0 through 4. Okay, and if I want, I can put anything. This lets me say what's in the array. Okay, so now the array has a -7 at the end. Okay, now if I want, I can say don't put anything in the array. This is another way to create an empty array. See, it's an array with nothing in it. It's maybe a little bit easier to read. This is a little, they're both correct. They're just two different ways of saying empty array. That's one way to say empty array. And this is just another way to say empty array. And you can check, let's go to Visualizer. See, they're both empty arrays. They literally mean the same thing. This and this just literally mean the same thing. If I wanted to create an empty array in my code, I might half the time type it this way, and I might half the time type it this way. They're just two different ways of saying empty array. This one's more general, and this one lets you say what's in the array. Why don't we use this all the time? Why do we even use this notation? If this is nicer and lets me say what's in the array, why would I want this notation here? There's a couple things wrong with this notation. What's one obvious thing wrong with that notation? It's convenient, lets you say exactly what's in the array, but when would I have trouble using it?
And you want to create a lot of numbers.
Yeah, what if I want an array of 1 million numbers? If I want an array of 1 million numbers, there's an array of 1 million numbers, okay? And I can do that. I don't think the visualizer is going to let me create an array of 1 million numbers. I can do it on my computer, but the visualizer may balk at it. Let's see. Notice it's taking a real long time. Finally, oh, look at the interesting message. Time limit exceeded, elapsed time. It took 14 seconds. It was trying to use too much memory, and it just quit. I mean, if you want to see that that's actually not a problem, you go over here and you create an array of 1 million items here. And notice it ran in just a split moment. It created 1 million numbers, filled it, found the largest and smallest, and had no trouble doing it at all. Okay, let me create an array of 1 million numbers holding the numbers between 1 and 5 billion. Okay, there's the number, no, see. Yeah, there's the number 5 billion. I'm creating 1 million numbers between 1 and 5 billion. Oh, that number is too big. Okay, so I can't create, let me make it 50 million. See if I think this one will be work. Okay. Okay, so I'm going to generate 1 million. Oh, 1 million numbers between 1 and 50 million. The largest number was this, and the smallest number was 24. Notice that, you know, on my computer, there's no problem using huge numbers, but the Java Visualizer doesn't like much of anything that's big. It's not meant for running things with large numbers, okay? So this notation is not going to work when you want large arrays, okay? It's not going to work when you want to use big arrays. There's actually another problem with it. What's another problem with doing something like this? Besides not being able to do it for large amounts of data, what else is restrictive about this? Remember, what are we trying to do down here anyway? What's our goal with this array?
Fill it with numbers.
What kind of numbers? See, here I'm filling it with numbers.
The largest and the smallest number.
No, that's what I want to find. What do I want to fill it with?
Between 1 and 500.
Well, but what? See, now I've got an array. This gives me an array of size 1, 2, 3, 4, 5, 6, 7, 8 items. So there's an array of 8 items. But what am I really interested in doing down here with that array? It's an array of 8 items, but what do I want to do down here? So what do you mean? Somebody wrote get numbers between. So what am I trying? What in a short? Try to describe it in the briefest amount of words. What am I trying to do? I want to fill the array with
Random numbers.
random numbers. Yeah. See, here I'm fixing what's in the array, but my real goal is to fill it with random numbers. So filling it with numbers that are predetermined isn't what I want here. So besides, so this notation's got 2 slight disadvantages. One is I can't do it with huge, I can't put 10,000 numbers here. And even if I have a small array, what if I want to fill the array with something other than a specific set of numbers? If I want to fill the array with random numbers, I can't use this notation to put random numbers in the array. I mean, I could pretend I'm using random numbers, but then I'd have the same numbers every time. You know, that's not random numbers because it's going to be the same numbers every time. See, that maybe looks random, but it's every time I run the program now, I've got those exact same numbers in it. I want to be able to make it so that every time I run the program, the array is filled up with a different collection of random numbers. So when you wouldn't want to play a game twice and have the die always come up the same order. The reason you use a die is so that when you play the game a second time, things come out differently. Yeah. So I want this to be the thing that fills the array differently each time. So I don't want to fill the array with specific numbers here. Okay. All right. So this notation, it's really nice to use for creating an empty array. And it's nice to use when you want a small array of very specific numbers. But it's not used as much as you might think. It's because a lot of times we fill arrays with data that we generate for some reason. We generate the data we put in the array. And often in the real world now, arrays tend to be large. Arrays of thousands and millions and billions of items are very common. So you're not going to have a list of 1 billion numbers here. Okay. Now, okay, so we've got this way of creating an empty array, this way of creating an empty array. We give them 2 different names. Now, let me show you even a third thing. Now, this is where things get a little bit tricky. What is this?
Empty array.
No, it's not an empty array. Yeah, that's the tricky part. It's not what we would call an empty array. Okay, anybody, what did that line of code do? We'll look at, go ahead, what? Read it from left to right. Well, yeah, read these things from left to right. We've said many times that this line of code does 3 things. Okay. And if there's any, if we accomplish anything in this semester, it'll be that you can remember what the 3 things that a line of code like this does. Okay. So anybody, what's the first thing this line of code does? Anybody remember? It's going to do 3 things. What's this do? You had an exam
Creates
last.
the size.
Pardon me?
Creates the size of the array.
Well, it creates it declares the size of the array, but what does it do? That's part of it. There's the size of the array, but that's just the 0. What about all the rest of these characters? What do they do?
Is creating a new object?
Yes, it creates a new object. Okay, and in the memory diagram, that's on the right-hand side. So this created an object, and that object was an array with nothing in it. Okay, so it created an object, an array object, with an array object with nothing in it. What did this side do?
Name the object.
Well, but that's not yet, not really. That's actually getting ahead of the game. What did that side do?
Made the object.
Pardon me?
Created the object.
No, we just said that's what the right-hand side did. This created the object, and it's an object with no entries in it. What does this do?
Stores the object.
Pardon me?
Stores the object.
No. Write this stuff down. Take notes. I'm not kidding. This is incredibly important. I keep coming back to this idea. You won't be able to write good Java programs if you can't tell me what the 3 things that line of code does. I'm not kidding you. You will not be able to survive data structures next year because things get way harder than this. You've got to know what the 3 things that line of code does. And you have to really understand it. So I keep coming back to it. This created the object. Okay, but what did this one do? Think of the picture we're going to draw. What did that one do?
Is it given the type?
Well, the type is over here. That's part of it. But that doesn't include the whole line. See, there's the type. It's the type of what?
Array, integer arrays.
No, this is the integer array over here. That's the object. So what does this side do?
Reference
Reference what?
the array.
No. The array is over here. This is the array. This is what? We've used these words over and over again. They were in the list of vocabulary for the last exam. They were in the list of vocabulary for the exam before that. What's this guy?
That's the name of the variable.
Yeah, it's the name of the variable. It's a variable. Okay, that's a variable. That's the type of the variable. It's a variable that names an array. So we call this, what kind of variable is that in Java? Remember, Java has several kinds of variables. What kind of variable is that?
Reference type.
Reference variable. That's a reference variable. It holds a reference to an object. Okay, that's a reference variable of type integer array. So it holds a reference to an integer array, which is over here. So this side creates the array object. This side creates the array reference variable. What does this do? Somebody gave the answer earlier. What does that thing do?
Stores.
No,
Object.
no. That's a
Sign.
bad way to think about it. Somebody else had an answer that was the better way to think about it.
It points to it.
Yeah, and what was somebody else used a different word.
Assign.
No, never think of it. Somebody else said something, I said that's wrong, but I said it's getting ahead of things. Somebody else said that this thing does what to this thing?
References it.
That's what we just said, but somebody else said something earlier. Try to go back. What did somebody say? Oh, yeah, I don't remember.
Oh, names it, I think.
Names it, yes. Yeah, it's another way to think about it. This thing now is a name for that thing. This is a reference variable pointing at that thing. This thing is a reference variable that refers to that thing. This is a reference variable that names that thing. Okay, but it was the equal sign that makes it a name for that thing. See, if without the equal sign, it would live by itself, but not be a name for anything. Well, I can make it live by itself without it being a name for, it can be a name that's not in use yet. Okay, so the left-hand side creates the name, the variable. The right-hand side creates the object that it will name. Then the equal sign says, oh, now he is the name for that object. Okay, and if we visualize it, there's the three things. Create the array, create the reference variable, create the reference between the reference variable and the object. The right-hand side creates the right-hand side. The left-hand side creates the left-hand side. And the middle part creates the middle part. Notice that this is actually laid out to make it so that it's kind of easier to remember. I mean, it literally is read, this case, it is read like from left to right. The name thing, the thing that's being named, and then the thing that associates the name to the thing that's being named. Okay, it really is three things. Okay, now what about this line of code 10? What does it do? Trick question. What does line 10 do? Easy answer.
It creates another empty array.
So what Yeah, it does three things, which are,
Raise the object.
no, three things. Three things. This does what?
The right side creates the empty array.
Yeah, creates the array object.
Yeah, well, yeah.
This creates what?
The reference variable,
Which will be
so
over
that,
here. And then
yes.
this does,
equates the two.
puts the arrow from one to the other.
Yeah,
Okay, so
yeah.
there's, see, another empty array, another reference variable, and the arrow to connect the reference variable to the array. Believe me, when you start writing the harder code that you have to write in data structures class, or when you have to start working with pointers in C++, which drive everybody batty, you have to go back to what I've just said and realize that if you can't read that line the right way, you're going to have a hard time with pointers, and you're going to have a hard time with data structures. Because what we're doing here is the crux of so many tough problems. People stumble on programming when they do not realize how to read a line of code like that. That it's object, reference, point the reference at the object. Now, line 11 is a little bit tricky. Line 11 does not do three things. Line 11 only does two things. Okay, one of them is easy. What does that do?
Creates a reference variable.
Yeah, so that creates a reference variable on the left. This does not create an object. So what it does is it puts the word null in the reference variable. There's no object over here. There is no object called null. And believe me, if you want to find out if a programmer knows what he's talking about or not, ask him if he's ever worked with the null object. If he starts hemming and hawing, if he looks like you like you're an idiot, then he knows what he's talking about. And if he starts hemming and hawing about the null object, the guy doesn't know what he's talking about. There is no such thing as a null object. So this line of code doesn't create a null object. There's no such thing. There's a special arrow. It's like a special kind of arrow. It's sometimes called the null pointer. It's a value you put in a reference variable to mean that the reference variable is not referring to any object. It's a variable that's not in use yet. It does not name anything. This guy names that array. This guy names that array. This guy doesn't name it. He's a name, but it's a name that's not in use yet. So it's holding this value that says this name's not in use. There is no such thing as the null object. So this line of code is not, that's where this stuff fails. You know, this looks like, we say this does three things. Create an object on the right, create a reference variable on the left, and make the reference variable point at the object. Then you look at this line of code, you would think, okay, I know what this is all about. Creates a null object, creates a reference variable, and makes the reference variable point at the null object. Wrong. Unfortunately, this one, you don't read it that way. This one only creates a reference variable and then puts the null value in the reference variable, and there's no object over here. And,
What?
yeah?
What happens if you later in the code try to turn the, obviously it's not actually a null object, but like
Yeah, now that was
change it
exactly,
and add values to it.
okay, that's exactly what I was going to show you. Good, because that's exactly what I was going to point out next. Now let's look at an example. Here's a simple example of what you want to do. I'm going to take this reference variable and call the length method on it and print it. And I'll do that with the other two. See, so here, try to do something with that null reference. Okay, now what does this do? Find the length of that. Now, am I finding the length of that reference variable? This is,
Yeah.
this,
Yeah,
this
so
has to be
that
read
line.
real careful. I'm finding the length of what?
The array.
Of which array?
Random ints.
Well, no, random int is a reference variable. I'm finding the length of which array?
So it'd be the first array object that was created.
Yeah, and it's the one named by this reference variable. Notice
Yeah.
that's a subtle distinction. I'm finding the length of the array object named by him. He's not an array object. I'm not finding the length of random ints. I'm finding the length of the array named by him. Because remember, in the picture, random ints was on the left-hand side of the picture. The object's on the right-hand side of the picture. The reference variable is not the array. The reference variable points at the array. So I'm not finding the length of this thing. I'm finding the length of the thing this guy points at. And that's why this stuff is tricky. The length of the thing this thing points at. And this is the length of the thing this thing points at. This is the length of the thing this thing points at. But that's a problem. What's the problem?
Random int 3 doesn't point to anything, it's null.
Yeah, so there's no length to compute. This line of code crashes. It's a lot like this line of code crashed because of what? They're not exactly the same, but they're similar. This tried to do what?
It's it's referencing an index that doesn't exist because
Yeah, it's trying to get at an item that's not there, right? It's asking you to get an item that's not there because how many items are in that array that this thing names an array with how many items?
0.
0
Yes.
items. So there's no item at that index. So I'm asking for something that isn't there. Here I'm doing something similar. I want the length of the thing this guy refers to. But that's mean I'm asking the length of something that isn't there. So it crashes. Two different ways of accessing something that isn't there. Here I have an array. I really do have an array, but the array has nothing in it. Here I have a reference variable, but the reference variable doesn't point at anything. So this guy crashes. Okay, visualize it. Create the array, create the array, create the reference variable that doesn't point at anything. Now, notice that the length of line 13 printed out 0. The length of that array, the length of the array that he points at is 0. The length of the array that he points at is 0. Blows up. Line 15 blew up my program. Okay? This does not point at any object. So there's nothing to compute the length of, so the program just crashes on you. It does not come back with a 0, because 0 would mean that there was an array that's empty. There is no array, so it does not say 0, it crashes the program. Notice that my buttons are grayed out. See, if I go back one step, I'm now about to do line 15. When I try to execute line 15, the program crashes. And I get this null, because that's this guy, null pointer. This guy is considered a pointer, the null pointer. Exception means that something went wrong. Exception is the word for error. It would have been better if it said null pointer error, but they used the fancy word exception. Exception means a program crashed. And Java tends to call these reference variables, but C++ calls them pointers. This is, I think, like the only place in the Java language where they let the word pointer slip in. The Java language is actually very adamant about these guys not being pointers. They're called references in the Java language. And somebody made a mistake and they let the word pointers slip in here. It's a little quirk. That's I think that's the only place I remember seeing anywhere in the Java language where they accidentally let the word pointer stick around. They, for technical reasons, Java references are similar to C++ pointers, but not quite. They're not quite the same thing. So they tend never to call these guys pointers. They tend to call them references. Okay? But here you see null pointer exception because they point at things. I mean, that's why C++ call them pointers. They point at things. Okay. All right. So these two lines of code are read one way, and this line of code gets read a different way. It only does two things. It created the reference variable and put the null in the reference variable. There is no object. Okay. Now, I can now do the following. I can change that so that this line of code does two things. What does it do?
It creates an array, and
Yeah,
then
that's the right-hand side, creates an array. Does the left-hand side do anything? Does it create anything?
no,
Because it's already been created. So what's the second thing this line does?
it names the array.
Yeah, it makes that reference variable point at that object. So it does create the object and then put the pointer in that reference variable. So I can go ahead and create the reference variable in one line of code and then give it a value in another line of code. So now here's what it looks like. Okay, it's a reference variable to nothing. It's a reference to nothing so far. And then in line 12, I say, oh, now pointed at something. Okay, see, so I can create the reference variable in one line of code and create the object for it in a different line of code. So if I want, I can do that. And then now this line down here will print out 5. Okay, because now this reference variable does refer to a real object. 2 empty arrays, an array that's not empty. Okay. All right. Okay. Let's see. Oh, what do we got left to go? We got about 5 minutes left to go. I lost track of time. We have like 5 minutes left.
Yeah, we have 5 minutes left.
Okay. Yeah, I lost track of time. I have a little. I try to set a timer on my desktop, and I forgot to start the timer today. So that I usually have a timer on my desktop to remind me how much time there is left. Okay, so we got. All right. So now see that. Now these kinds of lines of code, they're really important to keep track of what they're doing. It might seem picky at this point, but I'm really hoping that when you get to the data structures class or when you get to pointers in C++, even next semester, that really hammering away at these 3 lines of code like this will get you better ready to understand the harder stuff that comes up in both the C++ class and in the data structures class next semester. Because you will do subtle manipulations of pointers and references. And if you don't have a good sense of what a pointer and a reference is, it's hard to do subtle manipulations of pointers and references. Okay, so here we're doing real basic things. Next semester and the semester after it, you'll start doing pretty subtle. You'll be working with things called linked lists and trees, and you'll be doing all kinds of playing around with pointers. And so real simple picture, like from the point of view of programming, these are very simple pictures. Understanding these simple pictures forwards and backwards helps to understand the more sophisticated ones later on. Okay, all right, so we've seen now that we have an algorithm. We have an algorithm that has a precondition to it that it only works when you have a non-empty array. and that Java allows empty arrays, and the algorithm fails on an empty array because then you have these items that don't exist. You can't find the largest item in an empty array. You can't find the smallest item in an empty array. So you have no way of making the initial guess, so this doesn't work. Okay, so we see that even with a simple array traversal algorithm, that very subtle and important ideas come up. For example, the idea of a precondition. That an algorithm might only work when you specify ahead of time that it only works for non-empty arrays. Okay? So that's one important subtle idea. That even though you have a correct algorithm, you have to tell people, but it only works when you make sure that you don't give it an empty array. If you give it an empty array, you got a problem. And then we have the notion of empty array and also the idea of a null array, a null pointer. That empty array and null pointer are very different from the point of view of Java. To show you how tricky this is, the C language does not allow you to have empty arrays. This is not doable in the C language, and this is not doable in the C language. Not every language allows empty arrays. Okay, so Java does allow you to have empty arrays. Now the C language has this null in it, but it does not have the idea of an empty array. So Java has this kind of subtle idea of an array object with nothing in it. An array object that doesn't have any items in it, which is different than not having an array at all. In C, you only have two choices. There's no array at all, or the array has something in it. This is no array. This is, so in C, either array it exists and it's got at least one item in it, or it doesn't exist. Java has non-empty arrays, empty arrays, and null pointer, which means there is no array. Okay, so that's another subtle idea that not every language treats these things the same way. C doesn't let you have empty arrays, but Java does. Okay, so that causes programmers to get confused because in a language like C, you only have in a C programmer might say that that's an empty array because that's the closest they get to an empty array. They have no notion of actually literally an empty array. If there is an array object, it's got at least one item in it. So to them, that's an empty array. So you'll actually see programmers who aren't familiar with Java, who maybe only work in C, say things like talk about having, this is an empty array. But if a Java programmer thinks that, or if a C programmer looks at Java and thinks that that's an empty array, they're in trouble because that's not what's going to happen. That's very different than the empty array case. Okay, so we just, as soon as we start talking about traversing arrays, we start getting into some pretty subtle things here. Notice that you can traverse an empty array. There's no problem traversing an empty array. Actually, we didn't do that. Let's let Java step up to traversing the empty array. Okay, or I can't remember. Maybe we did do this. Okay, here's Java trying to traverse the empty array. Okay, so it's going to create the array index, I is 0. Now it's going to go over here. The length of that array is 0. So the length is 0. 0 is not less than 0. So it skips. So this is false. So it skips over it. Okay, so you can traverse an empty array. See, we just traversed an empty array. You basically skip over the traverse. But that for loop did get executed. Okay, so that's a very subtle thing. We traversed an empty array. Okay, that's not the same thing as somehow skipping over the empty array. We still did do the for loop. The code for the for loop worked perfectly fine for either a non-empty array or an empty array. But if I put, it won't work if I give it a null array. Okay, if I okay, now this guy's a null array. And if I try to use the null array here, I cannot traverse a null array. Okay, now I'm going to have trouble. I initialize this variable. Now I need to do this test. What's going to happen?
It will
There's the
crash.
reference variable.
Won't your code crash?
Yes, because of what?
The random it's 3 at that length.
Yeah, what's wrong with it? See, these are interview questions. Okay, what is wrong specifically?
It doesn't exist. It's a null.
Yeah, so random int 3 is a null reference. There is no object. See, yeah, if you want to answer the question properly, what people interviewing are going to be waiting for you to use the word object. There is no object to call length on. See, there's no, see, length would be called not on the reference variable, it's really called on the object over here. So you follow the reference variable to the object, then you call length on the object. So there, since this is a null, there is no object to call length on. So it crashes. So if this was an interview question, people would be wanting to hear you use the word object and know, that there's a null reference. So there is no object to call length on. So that failed. Okay. So I cannot iterate over a null array, but I can iterate over an empty array. I can traverse an empty array, but I can't traverse a null array. That doesn't make sense. Okay, so that's subtle. So this array can be I can traverse that array, I can traverse that array, but there is no array here to traverse. Another way to put it is, just because I have a reference variable doesn't mean I have an array. So I'm not really traversing an array here because I got a reference variable, but no array. Okay, so that code, that one now fails. It crashes. Okay, but you want also you want to be able to tell people what's going on with the language they want to hear. They want you to say that that reference variable is null. So it does not refer to an object. So there's no object for that thing to be acting on. There's no object to compute the length of. You're not computing the length of that reference variable. That doesn't make sense. You follow the reference variable to the object, then you find the length of the object. The reference variable doesn't have an object to point at. So that's the careful way to answer that question of what goes wrong with that line of code. Okay, now, notice how much we can say about a simple array traversal. We can say a lot starting with just the idea of an array traversal. Here we wanted to find the max and min of the array, and we get into like real subtle arguments about what about an empty array? What happens when you have an empty array? Well, it's kind of hard. It's kind of hard to say what the max and the min of an empty array are, and that's why this algorithm has a little bit of a trouble. What's the largest number in an empty array? What's the smallest number in an empty array? If you think of it, there should be some issue with this code because that's a hard thing to answer. What is the largest number in an empty array? There's nothing in the empty array. Okay. If you ask this of a mathematician, they do have an answer for that. There is a logical answer for what's the maximum number in an empty array. And the answer is real surprising. The answer is negative infinity. The maximum of an empty array is negative infinity, and the minimum of an empty array is positive infinity. Yeah, and if you think real hard, you realize they're right. And I won't try to explain to you why they're right, but there actually is an answer to that question. The max of an empty array is negative infinity, and the minimum of an empty array is positive infinity. And it's not what you think. You think that the minimum of an empty array would be negative infinity, and that's not actually what it is. It's maximum of infinity. Yeah, it's really weird, but it turns out that in logic, you can make sense of that idea of the max and min of an empty array. And Java will, if you write your code real carefully in Java, you can actually give that answer. We won't do it that way. We'll just not call, we will not try to find the max and min of an empty array. But in more professional Java code, you actually should give those correct answers. A professionally written program to find the max and min of an array should return an answer for this case of an empty array. It should return, if the array is empty, the max should be negative infinity and the min should be positive infinity. Okay, and later on in the data structure class, you might actually see how to answer that question. Sometimes we do that in the data structures class. That's because that's not an unreasonable question to answer at that point. But it's not worth going into the details of it here. But there is an answer to that question. Okay, all right. So let's quit there. And what we're on Thursday, we got one more example to do of searching an array, and then we have something called array methods. So we're gonna talk about searching an array, which again, it's a simple problem, but it brings up touchy issues. So it turns out to be a simple problem that's not as simple as it seems like at first. Okay, just like finding the max and min turned out to be more subtle than it seemed to be, searching an array also turns out to be a little bit more subtle than it seems to be. And then we're going to look at we're going to look at the connection between methods and arrays. Okay, that's something that's also real important. How do arrays interact with methods? And it turns out to be there's some subtleties there also. That when you want to call methods with arrays, or if you want methods to return arrays, that you have to be very careful about how you do things. Okay, so I'll put these examples up on the website after class in a little while. And if you have any questions, send me email. And also, like I said, I hope exam 1 will be graded by Thursday. Okay, if anybody came in late, early, at the beginning of class, I mentioned that I started grading exam 1, and I hope that the exam 1 will be graded by Thursday. And if you have any questions about, you've got the grade for exam 2. If you have any, look over your exam 2. If you have questions about it, please send me email or come to office hours. Okay, so I'll go ahead and stop here, and we'll meet again in a couple days. Bye.